as stated by, as given by Ohm's
This
law.
call is now being recorded.
And
This call is now taking notes.
we also saw how that we could calculate problems using Ohm's law. So we solved some little questions involving some circuit diagrams and then things like that. And as I always do say, the things you miss can always be checked out from the video. Just you go back to it and then see everything for yourself. All right, but today we'll be looking at aspect, another aspect of physics, and I want us to look at vectors. Remember, our exam is very much at hand, and then we are trying to see how much we can, how far we can cover up with some of those topics that are needed in your exam. So every topic we're dealing with is very, very important. The ones we did before when we started the class, all those topics with the simple harmonic motions and the rest of that, waves, and then those aspects. Every topic, every single topic is important. So today I want us to look at vectors. Vectors. I want to believe an average student here should know what a vector is. Primarily, we have two quantities, or quantities in physics are split into two types. We have the one we call the scalar quantities. We have the one we call the scalar quantities, and we also have the ones we call vector quantities. Now, what are scalar quantities? Scalar quantities are simply quantities that has only magnitude without direction. So they don't have any direction. And when we say magnitude, we mean they have numerical values, they have size, all right? But they don't have any reference with what direction. An example of such quantities are your mass. Your mass is a scalar quantity. It doesn't have anything to do with direction, distance, energy, and the rest of that. So there are many scalar quantities. You can check them out to yourself. But today we're looking at vectors, and we say that vector quantities, these are quantities that have both magnitude and direction. So they have numerical value, they have size, and they also have direction. An example of this, so take notes, they have both magnitude. These are quantities. These are, I'll be explaining many things. I won't be doing so much writing until I get to the equation aspect of this. So these are quantities that has both magnitude and direction. So just like the scalar quantities, we have examples also for our vector quantities. And examples of vector quantities include force. So examples are, we have force, we have velocity, we have acceleration, we have weight, which is gravitational force, we have displacement, and the likes. We have many of them. So you can always check out other examples. All right, so these are quantities we call vector quantities. Remember, they have both magnitude and direction. It means that in addition of vectors, we have to always put their direction into play. In scalar quantities, we don't consider direction, all right? Let me give you a clear example of what I mean. Now, let's say a boy, this is just to illustrate what I'm trying to say. So let's say a boy walks 5 kilometers due east. So a boy walks 5 kilometers due east and then walk back 5 kilometers due west. Then walk back 5 kilometers due west. Now the question says, what is the displacement of the boy from his starting point? What is the displacement of the boy from his starting point? Now clearly, if the question had said, what is the distance covered by the boy? The distance would have been to add up 5 plus 5. That gives me the total distance, all right? Because in this, distance is a scalar quantity and we don't consider directions. But in this case, this is where the boy started. He started from here and the boy is still ending the same at the same point, because by the time he walks back 5 kilometers, you find out that he's still at the same point. He has not really moved any distance. All right. So if they say what is the displacement, the displacement means from the point where he started, how much distance has he covered? All right. So at this point, the boy has covered zero distance as long as that direction is concerned. So it means that if they ask you for the displacement, first of all, let me total distance covered by the boy. Remember, distance is a scalar quantity. Is 5 plus 5. So this boy must have covered 10 kilometers. All right. But the total displacement covered is going to be 5 plus minus 5. You see that 5, because this 5 is moving on the positive x-axis, positive x direction. This other 5 is on the negative x direction. So we need to consider the direction of the two quantities. All right. So the first value was positive, second was negative. So because they are they are moving in separate directions, we need to consider that direction in adding our vectors. And of course, you know that plus minus is minus. So this is more like saying 5 minus 5, and I'm going to get 0 kilometers. So it means that from the starting point, the boy has actually traveled 0 kilometers. All right. So these are the things to take note when you are dealing with vectors. You have to know that in vectors, we consider the direction. All right. So if the boy started 5 kilometers and walked back 3 kilometers, from the starting point, he has only covered 2 kilometers, which is just 5 plus minus 3. That's 5 minus 3, and I'll have 2. Meanwhile, if I'm to consider the total distance without considering the direction, so I'm just going to do 5 plus 3, and I'll get 8. All right. So get the difference when you're trying to add up vector quantities of this form. All right. So also, when vectors, I'm trying to just do a brief recap on some basic things before we go into how we can find the resultant vector. All right. I'll talk about resultant vector, but just get these basic ones. Also, let me still use similar examples. Right. Now, let's say we have a question where they say a boy travels 5 kilometers, 5 kilometers eastward, and then let's say let me try to use, okay, let's say 12 kilometers northward. Now they ask us to find what is the total distance covered, what is the total distance, and the displacement of the boy from his starting point. So this is a question. Now, I'll try to sketch a diagram. Remember they said a boy travels 5 kilometers eastward. I want to believe every one of us understand our cardinal point, all right? So when they say eastward, this is more like your cardinal point here. Here we have the east. Oh, sorry. Here we have the east on the right. We have the west here. We have the north here, and we have the south here. All right. So they said the boy walk 5 kilometers eastward. So this is where the boy moved. He moved this way from here to here. Let's call here 5 kilometers. And he traveled. Vectors are usually represented with an arrowhead. The arrowhead depicts the direction of that vector. They now said the boy then walked 12 kilometers northward. All right. So northward means from where this is where the boy is now. He's here, 5 kilometers. He's now at this point. He now northward, from there he went up. Remember, northward means he went up. That's a north direction. And he covered about 12 kilometers northward. So this is where the boy is now. So this is 12 kilometers. Now they want us to find the total distance. All right, the total distance will simply be to add up the two values. So total distance will simply be 5 plus 12. And this boy covered 17 kilometers. But they also said we should find the displacement of the boy from the starting point. What is displacement? Let me try to define displacement in two ways. Meanwhile, firstly, displacement is distance in a specified direction. And also, you can define displacement as the shortest distance from your starting point. So this boy was initially here, this is where he is, and this is where he is now. All right. So the shortest distance will be the line from here to here. So I'm going to join the line here. So that becomes the displacement. So this place is a displacement of the boy because that is the shortest distance from here to here. Meanwhile, notice that the boy traveled 17 kilometers to get to that point. Now let's find what the shortest distance would be, which is actually the displacement of the boy from the starting point. And clearly, you can see that this is a right angle triangle. And how do I find the side? What's the relationship in finding the size of a right angle triangle? The relationship is such that we need to use our Pythagoras theorem. Remember, Pythagoras theorem says that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So it means that clearly I'm going to find my displacement at d square is equal to 12 square plus 5 square. And that gives me 144 plus 25. And what if 144.25 is going to give me 169. So my d square is 169. Therefore, my d alone becomes the square root of 169. And that gives me 13 kilometers. You see that? So the shortest distance from the starting point is actually 13 kilometers, which is what we call displacement. But this boy, other than going 13 kilometers, he went through the wilderness journey, if I may say. So he went through the long journey, covering 5 plus 12. He got to that point, that's 17 kilometers. But actually, in real sense, what he covered from the starting position is what? 13 kilometers, if we are to consider the shortest distance. And that's exactly what that question entails. That's what that question entails. All right, so what I just showed you is that if the question given to you is such that the boy or the motion is still on the same plane, so we are still on the same plane, you need to just consider the direction and add up the vectors. If they're in opposite direction and they're asking you to find displacement, of course, or they're trying to asking you to find the sum of those two vectors acting in opposite direction. So what you're going to do would be to simply what? Add up the two vectors, but just consider their sign. So in adding up, let's say I have a force 5 Newton. Here, I have another force acting this way, 3 Newton, and they ask me to find what is the resultant force. The resultant force will simply be 5 plus minus 3, which simply means 5 minus 3, and I'll get 2 Newton. All right, that's my resultant force. Why? Because force is a vector. Do you understand that? Force is a vector, and if one is moving this way, the other is going the opposite way, then I have to consider the direction of the forces, and I just have 2 Newton. All right. So when the vectors are in opposite direction, you in adding you subtract. But when they're in the same direction, you do the normal addition, But that is not the case of scalar quantities. In scalar quantities, we don't take reference with their what direction. So that is just a little explanation on that. So these are basics. All right. Now, how then do we find? Let's look at resultant vector. I've talked about resultant vector now. So now, what exactly is resultant vector? Resultant vector. Now, resultant vector, you may write, resultant vector is that single vector which would have the same effects. Let me try to put it down. Resultant vector is that single vector which will have the same effects in magnitude and direction as the original vectors acting together. All right, so this is how we define a resultant vector. So we say is that single vector which will have the same effect in magnitude and direction as the original vectors acting together. You see that? So back to the question I just did now. If I go back to that question, now this was the question I solved. I try to use this a vector moving this way, 5 kilometers, another vector move up 12 kilometers, and they asked me to find the resultant vector. So my resultant vector is this displacement I found here. You can see that it has the same effect in both magnitude and direction as the original vectors and the other way. Okay, I think my network glitched out. Okay, can you hear me?
Yes, sir.
All right. So in this case, I have vectors acting, one acting due east, the other acting due north, and then we are asked to find the displacement. That displacement is actually called resultant. Why? Because it's called resultant vector. Why? Because it has the same effect in both magnitude and direction as the original vectors that are acting together. So this is how we find or how we define a resultant vector. Now, in finding resultant vector, basically, there are two methods you must know, and I only teach one because many of times, the way the questions comes is that you'll be asked to use this method, or you might not even be asked to use any method. You've just be given a question and you're asked to solve. All right. So have it in mind. There are two methods of finding the resultant of two vectors. So one of them is called the parallelogram method. Parallelogram method. And then I have also the triangular method. So these are two methods involved in finding resultant of vectors, especially, in fact, in this case, these two methods applies when the angle is beyond 90 degrees. All right. When the angle is beyond 90, it's not 90 degrees. That's the point. When the angle is not 90 degrees and you're asked to find the resultant, you can either do that using the parallelogram method or you can do that using the triangular method. But triangular method is basically I'm using constructions. All right. We have to use constructions in doing this. This is the one that involves you making calculations. And for you to use parallelogram method, we need to know what the parallelogram law is all about. Because in parallelogram method, we need to understand the parallelogram law of vectors. So let's take that as a heading. Parallelogram law of vectors. Trying to be a little bit fast so we can cover up some few things before the end of the class. All right, so what is parallelogram law of vector? What does it state? This law states that when two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the law says that the diagonal drawn from their point of intersection represents resultant force. That is just the law. All right, so let me try to see. It said when two vectors, this states that when two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram. It said the diagonal drawn from their point of intersection. The diagonal drawn from their point of intersection represents resultant force. Represent resultant force in both magnitude and direction. In both magnitude and direction. Okay, this is just the cosine rule. This is the parallelogram law of vector. So it says when two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, it said that the diagonal drawn from their point of intersection represents resultant force. Now, what are we trying to say? Now, this is a parallelogram. A parallelogram is like this. This a parallelogram looks like. These two sides are parallel. So this side is parallel to this side, and then this side is parallel to this side. So remember, the sides facing themselves are called opposite sides. All right. So this side and this side are opposites. This side and this side are equally opposites. Now, this side and this side are called the adjacent side. Also, this side and this side are called adjacent sides. All right. Now, what then does the law state? Now we've known what adjacent and opposite sides are. It said anytime vectors are represented in magnitude and direction by the adjacent sides of a parallelogram. So let's say I have a vector represented here. So this line, this is my vector, first vector. So let me say I have this as my F1, and I have also this side representing F2. So these vectors can be shifted in space by completing this parallelogram. So this side, I can move it to be completed like this, which is the parallelogram I drew. This side, I can equally move it this way to be completed as this. So it means that if this place is F1, here also is F1. If here is F2, this point also is my F2. So I have two forces inclined, and I've been able to, let's say this, their angle of inclination here is what? Angle theta. So they are inclined at an angle. All right. So these two vectors, the law says that anytime vectors are being represented by the adjacent sides of the parallelogram, that the diagonal drawn from their point of intersection. So if I draw this point like this, if I trace a diagonal from one point to this other point, that diagonal is called the resultant force, R. So let me try to cut out a triangle from what I just did right here. If I try to cut out a triangle, I'll be having something like this. I have a triangle looking like this. Like this. This is what I have. So this is more like a triangle. All right. So this is my triangle cut out from that parallelogram. So this is my resultant force. So this place is my F2 and this place is my F1. Now, an angle is going to be formed here. And this angle here is actually equal to 180 minus the angle here. So anything the angle here is, you subtract it from 180, that will give you the angle here. All right. So this place here, let me call it 180 minus theta. You see that? That's the angle there, because the angle of inclination is actually theta, which is the angle where the two vectors are being inclined. Now, another angle will be created here, because when you do the diagonal, you find out that a portion of this theta will be formed on this triangle. And we can't say that that portion is half theta. No, we need to calculate that angle, because many a times the angle or the line doesn't just pass through in between, doesn't cut straight in between that value. So you can't say that the value here is theta divided by 2. No. So we can call that value alpha. So meaning that at this point, I can use the relationship between the size and angle of a triangle that is not right angle to find this resultant and that angle. And what would that relation be? That's my cosine rule. Clearly, cosine rule states that anytime you have two known sides, which is your f2 and f1 in this case, and now you have a known angle facing an unknown side. See, I know this angle here. This angle here is 180 minus theta. That's the value here. So I know an angle, and that angle is facing an unknown side, r. That we can find r using the cosine rule, which says that r squared is equals to f2 squared plus f1 squared plus multiplying plus 2 times f2. Let me just write it together. Plus 2 times f2. No. This is a minus, not a plus. So r squared equals f2 squared plus f1 squared minus 2 times f2 times f1, then cosine that angle facing r, which is in this case 180 minus theta. So this is actually cosine rule. This cosine rule. What I did here is just applying cosine rule in solving problems like this. Do you understand? So we can actually use an example to illustrate what I did, because the way it is right here, it looks a little bit confusing, but it's basically the same thing, the same cosine rule, And then in solving for this angle here tells us the direction of the vector, all right? And if you're being asked to find the direction of the vector, you need to calculate the value of this angle. And in this case, I called it alpha, all right? And you have to use, you're going to use your, what is it called now? Your sine rule to find the value of alpha. And how would you find the value of alpha? Sine rule. What does sine rule state? Sine rule says that sine A all over A is equal to sine B all over B, also equal to sine C all over C. But in the case of this, my diagram here, from what we did, so I'm going to have that sine alpha all over f1 is equal to sine 180 minus theta all over r. And that will be the sign we'll be using in solving for that direction when the time comes. So let me write it out. So we have that this implies from our diagram that sine alpha, the angle, all over what? f1, which is one of the given sides, f1 is equal to sine of angle 180 minus theta divided by what? R, which is our resultant force. So if you find the resultant force, you can find the direction of the vector by using your sine rule, which I've just written down in this very form. Okay, now let's try out an example, how to engage this formula. Now, look at this vector, look at this question, example. This is actually a past question. They said, find the resultant of two vectors, 3 units and 4 units. Find the resultant of two vectors, 3 units and 4 units, acting at a point O, at an angle 45 degrees each other. At an angle 45 degrees with each other. Hence, find the direction of the two vectors. Hence, find the direction of the two vectors. Find the direction of the two vectors. So this is a past question. This question was extracted from the past SSCE. All right. So we are given, they said we should find the resultant of two vectors, 3 unit and 4 unit. acting at a point O at an angle 45 degrees with each other. And they also said we should find the direction of the vectors. And this is a very simple question. Once you know your cosine rule and you can sketch this into diagram, then everything becomes as easy as ABC. Now let's look at the solution. The solution is such that they said 2 vectors, 3 Newton and 4 Newton. So they said they are inclined at an angle 45 degrees. So let this be this is my 3 Newton. Let me try to sketch it. Remember, in vector, you have to consider the size. So this is my 3 Newton. 3 Newton should be smaller. Okay, let me make this 4 Newton. This is my 4 Newton here. This is my 3 Newton here. 3 Newton. This is my 4 Newton in a parallelogram. So I've been able to sketch them. Now, the reason why I drew this like this is because they told us that the angle between them is 45 degrees. And clearly, this way is 90 degrees. This is 90 degrees. So 45 should be halfway or 90. That's why this triangle, these angles are being, these two vectors have been inclined in that way. So between, I'm going to put angle 45 degrees. All right, they say we should find the resultant and equally find the direction. So this is the information I need. The next thing I have to do is to shift this vector in space. Remember, these vectors were moving in this direction. And now, if I try to move this 4 Newton this way, what I'm doing is shifting vector in space without changing their direction. So also, I can move the 3 Newton this way just to make up my parallelogram. So this is my 4 Newton. And then if I move the 3 Newton this way, I'm using a dotted line to show that those were not part of the given diagram. All right, so I brought it in because I want to use the parallelogram method in solving the question. All right, so having done this, this is still 4 Newton. And this point here is still 3 Newton. You see that? Now, the law says that the diagonal drawn from the point of intersection. So this is my diagonal here. This is my diagonal. So this diagonal, please, is a straight line. Let me attempt making a straight line again. All right, this is better. So the diagonal drawn from the point of intersection represents resultant force. So this is what I have. So from here, I can make out the triangle. So the triangle will be such that I'll have something like this. I have something like this. So if I join it point to point, okay, let's manage that. So this is my resultant force R, and this place is 4 Newton. This place is 3 Newton. Please, the diagram, try as much as possible to try to make it look like, of course, 3 Newton should be bigger than, should be less than 4 Newton. The 4 Newton line, okay, let me even correct that. So it doesn't look like, because these are vectors and we have to consider the length of the line in sketching our diagrams. All right. So something like this. Yes. So clearly this place is 4 Newton. So this is 3 Newton. And this is my R. Remember, I told us that the angle here will simply be 180 minus the angle given to us here. And what angle was given here? 45. 180 minus 45, that will give us 135. So the angle here is 135 degrees. And then this other small angle that will be formed from here is called the direction of the vector. So let me call that direction alpha in this case. So this said we should find R, which is the resultant force, and equally find alpha, which is the direction of the vector. All right. So how do we find R? We have to use the cosine rule. And in using the cosine rule, we have that. So solving for R using cosine rule. So the cosine rule states that my R square, if I apply that, is equal to 4 square plus 3 square minus 2 times 4 times 3 cosine 135. So you see that. Remember the formula we stated before, that r square equals to f2 square plus f1 square minus 2 times f2 times f1 cosine 180 minus theta. And we've done the whole of that, and that is how we got this expression here, that r square equals 4 square plus 3 square minus 2 times 4 times 3 cosine 135. So clearly, we can solve further. R square becomes 4 square will give us 16. 3 square will give us 9. Minus 2 times 4 times 3. That will give us 24. 8 times 3. And we have 24 cosine 135. You see that? So our R square becomes 16 plus 9. That will give us 25. We have 25 minus 24 cosine 135. So I can't say 25 minus 24, no. So I have to first of all find the value of this, because these two things are multiplying themselves. And of course, before you can subtract, you have to first multiply. So someone should help me. What is 24 cosine 135? So someone should check that out for me. 24 cosine 135. Please, what is the value of 24 cosine 135? Someone should help. Is someone listening? All of you don't have calculator. What is the value of 24 cosine 135? Why is no one responding? Minus what?
16.9.
Minus 16.9. So it means that I'll be having minus 16.9. All right. So clearly, this means that my r square becomes 25. Double minus is going to make a positive. So I have 25 plus 16.9. And if you add 25 plus 16.9, my r square becomes, that will give me 41.9. 41.9. That's the value, right? Yes, that's it. 41.9. So my r square is going to be the square root. My r, remember r square is 41.9. So therefore, r alone becomes the square root of 41.9. And what then is the square root of 41.9? That would give us about 6 point something. I don't know. So let's say 6 point something. You can check that. Maybe let's say 6.5 units. So you can check that from your calculator. It should give us around. Please confirm. What's the square root of 41.9?
6.4. And it's 6.5.
6.5. Oh, I was even very correct. Okay, so 6.4 units becomes the resultant force. All right, so we found the resultant force. Now, the next thing we're going to find is to find the direction of the vector. The direction. How do we find the direction? Using sine rule. So solving for the direction of the vector, which is our angle alpha, right? So remember we said that sine rule, sine A over A, sine capital A, which is sine angle over the side, is equals to sine this angle over the other side. And back into, look at the question we have. Okay, let me try to sketch the triangle again. This is what I have. This is what I have, the triangle. Oh my goodness. Okay, this is like the triangle I have before, just trying to sketch it. Okay, let's try one more time. Let's do something better. Okay, this basically the triangle I have before. Now we found the resultant force R and we got 6.5. This is what I have. And in it, we found this angle from the previous triangle, and this angle here is 135. And I'm looking for this angle here, which is alpha. But I already know this side here is 4 Newton, 4 units, and this other place is 3 units. You see that? So in solving for the direction, which is alpha, I already have an unknown angle facing a known side, which is 3. And in this case, I have a known side with a known angle. So it means that my contrast is going to be that sine alpha all over the side facing alpha, which is 3, is equals to sine 65 all over the side facing 6.5. Please, that's sine 135, I mean. Sine 135 all over the side facing 135, which is 6.5. You see that sine this angle alpha, the side facing alpha is actually 3. So I can actually use 4 because I don't know the angle here. So I can't use that value 4. So I can only compare 135 and then 6.5 and then alpha and the side 3. And from here, if I try to make alpha the subject, I'll be having that 6.5, if I cross multiply, 6.5 multiplying sine alpha is equal to 3 multiplying sine 135. And clearly, if I divide both sides, my sine alpha alone becomes 3 sine 135 divided by 6.5. So what is the value of 3 sine 135 divided by 6.5? So someone should check 3 sine 135 divided by 6.5. I'm listening. 3 sine 135 divided by 6.5. Anyone there should tell me your value.
Zero point three three.
What? Say that again. 0 point what? 0.33. Make it 4 decimal place, please. 0.33 what? Papa, me make it 4 decimal place. 0.33 what? Okay. So if sine alpha is 0.33, our alpha alone becomes the sine inverse of 0.33. So what is the sine inverse of 0.33? Please, what's the sine inverse of 0.33? You guys are used to just being in class, not making, just making zero contributions.
90.26.
19 point what? 19 point what?
26.
19.26. Let's call that 19.3
26.
degrees. And this, all right. So 19.26 is just about 19.3 degrees. That's if you have to leave the answer in three significant figure, which is one decimal place. So we've been able to solve for the resultant force. So if I'm to sketch this diagram again, that diagram, I'll be having something like this. This place gave us 19.26, which we said is 19.3. I have that angle there to be 19.3. This angle is 135 degrees. R is 6.5. Here is 4, and this other place 3. So this is actually what the solution to that question looks like. Do you understand? So clearly, our direction of the vector is 19.3, and then our resultant vector is 6.5. So notice I use the cosine rule in solving for the solving for the vector, the resultant vector itself. And then I use the sine rule in finding the direction of the vectors. So this is how the question is being done. And I want to believe you understood that. Let me give you the one you try. Can I do a quick recap? Right? We won't have time to solve more questions. Meanwhile, you guys are giving zero vibe in this class. But take down this question. I will ask you for the solution in the next class. So the question says, find the resultant and the direction of two vectors. So this is just like an assignment. I stopped posting assignment on the platform since I knew you guys don't always attend to it. So I stopped that. So take down this one. Find the resultant and the direction. Find the resultant and the direction of two vectors. Five Newton and 4 Newton acting at a point O at an angle 30 degrees with each other. Okay, so these are your assignments. So you just try it out and then we'll meet in the next class. You tell me what your solution is. Or better still, when you're done, just try to post it on the platform. All of you on the platform, I want to believe the WhatsApp platform is created for every one of you. So when you're done solving the question, you can just make a post there. Try to send it across, or you can send it to me directly even. And also, if you have a question, always try to reach out, okay? If you have a material or something you think you know that will be beneficial for you in preparing for this exam, or maybe there is a topic you want us to treat, don't just leave all these things for the teacher. You can just decide, or you can come up, oh, this topic is quite difficult. We've not done this and that. Sir, please, this is the one you do for us in the next class. That becomes the topic for the next class. Because the essence of the whole thing is just to prepare you guys for the forthcoming exam. And you guys have less than 1 week to even prepare. Yes, Obaomi, I can hear you. Obaomi, you were saying something. Okay, so let me do a recap on the things we've done today. we started by looking at what a vector is. Firstly, we talked about the two types of quantities. We said we have the scalar quantity and then we have the vector quantities. And then we say for the scalar quantities, these are quantities without direction. They only have magnitude or numerical values. And I gave you examples of these quantities like your distance, your time, your length, temperature, speed, density, the rest of that. So many of them, there are many scalar quantities. And then I said in vector quantities, these are quantities with both magnitude and also direction. So they have both magnitude and direction, meaning that in solving question on vectors, you must consider the direction of that vector. Do you understand? So I gave an instance. If they said a boy walk from a point A to B and then walk back from B to A, and then they're asking us for the resultant displacement. Now notice displacement is a vector, so I have to consider the direction. So if the boy walk 5 kilometers east and walk back 5 kilometers west, resultant displacement is 0 because the boy is still exactly where he started. You see that? But if they said find the resultant, what is it called now? The resultant distance. If they ask you to find the distance, you do that by simply adding up the values. All right. So the bottom line is that in solving for displacement, you consider in solving for vectors, you must consider the direction. When they're in opposite direction, it's more like you're subtracting. All right. And I also said if these vectors are inclined in angle 90 degrees, the way to find the resultant vector is to use your Pythagoras theorem and solve for the unknown side. And we saw an example on that. And then we talked about resultant vector. And I said it's a single vector that has effect in both magnitude and direction as the original vectors that are acting together. And we saw the method, how we can use the parallelogram method in solving for resultant vector. And I also gave us a parallelogram law, which says that when two vectors are represented in magnitude and direction by the adjacent sides of the parallelogram, that the diagonal drawn from the intersection point represents the resultant vector. And I showed us how that resulted to using cosine rule to solve for the triangle cut out from that parallelogram. And we saw that. And in this example we just did right here, we saw a simple application of that resultant force of that parallelogram law. We used it cosine rule. We could find the resultant for using cosine rule, and then we use the sine rule in solving for the direction of the vector, and that is that was how we arrived at this very result you are seeing here. And I gave you this assignment to try out yourself. So we'll meet in the next class. We continue. We'll look at in the next class. I can't hear you about me, but
I
okay,
said,
say that
when
again.
are
What
you
did you say?
teaching practical?
What am I teaching you when?
Physics practical.
Okay, your physics practical. The practical is still far, but even though I might not be able to in the practical, you are not here at the experiments. What I'm going to do is that I'll try to do the experiment when the specimen is out. If the specimen is out, that's your YX specimen, I will do the practical myself using those specimen. Then I will show you the result and then how to plot your graph and the things you need to know. So we can't do the practical because we are not physical. So, and then we just try to give you basic nuggets, things you will need to navigate your practicals. Do you understand that? So that's what we do. So I'll try to do the experiment. I will explain everything I will do in the experiment. And then when I explain that, give you reading. So just in case you are, because the practical will be, you'll be given 3 practicals. And out of those 3, you'll be expected to do just 2 practicals. Do you understand that? And that's how it will be. So in our next class, we'll look at resolution of vectors. There are resolution of more than 2 vectors. So that's what we'll do in the next class, just to complete this session. And maybe subsequent class, we may just, when the specimen comes out, we may now consider the practical, just like you suggested about me.
But that the boot camp will have expired.
The what? The webcam, yes. When what week are we in right now? When is the class going to expire?
This month.
Yes, I know this month, like when the point is that we can't do practical without the specimen. Do you understand that? Because every year WAEC releases specimen, unless you're saying we should just do it wouldn't even make sense. We can do practical based on maybe specimens that has been given, other practical, like a kind of review. But if you really want a practical guide on what you should expect, then it means we have to wait for specimen. But let's see how it goes. Before the class ends, I'll try to give you an OT, an orientation on how to navigate your practicals. All right. So I don't know how many classes we have left before the end of the maybe the last class before the end of this class. Our very last class, we'll try to do a practical, just a run through on what to expect on that practical day. Do you understand? Okay, in the absence of that, I think we'll bring the class to a close. Thank you for joining. We have how many? 3 persons here. So we'll see in the next class. Do have a good evening.